The journey of artificial intelligence from theoretical concept to everyday reality represents one of humanity's most remarkable technological achievements. In 1950, when Alan Turing posed his famous question, "Can machines think?" the notion seemed purely fictional. Today, AI has become deeply woven into the fabric of our daily lives, from facial recognition on our phones to spam filters in our email, social media feed curation, and GPS traffic prediction. The birth of artificial intelligence as a field can be traced to a pivotal moment in 1956 at Dartmouth College. There, luminaries like Marvin Minsky, who would later found MIT's AI laboratory, John McCarthy, creator of the Lisp programming language, and Herbert Simon, future Nobel Prize winner in economics, gathered to explore the possibility of creating thinking machines. These pioneers believed that within decades, machines would match human intellectual capabilities across all domains. While their timeline proved optimistic, their vision set the stage for decades of innovation. The early years saw both breakthroughs and setbacks. Arthur Samuel's Checkers program in 1952 demonstrated basic learning capabilities by eventually outplaying its creator. Frank Rosenblatt's perceptron in 1957 marked the first artificial neural network capable of recognizing simple patterns. However, technological limitations of the era, slow computers, expensive memory, and primitive algorithms led to what became known as the AI winter in the 1970s, when funding and progress stalled. The field experienced a renaissance in the 1990s with the rise of machine learning, which fundamentally changed how we approach AI. Instead of programming explicit rules, these systems could learn from data, identifying patterns and making predictions. The development of neural networks, inspired by the human brain's structure, proved particularly revolutionary, with interconnected nodes processing and passing information through multiple layers. A watershed moment came in 2012 when AlexNet, a deep learning system, achieved unprecedented success in image recognition. This marked the beginning of the deep learning revolution, leading to systems that could process speech, translate languages, and even create art. The technology has advanced so rapidly that applications once considered impossible are now commonplace. Natural language processing has seen particularly dramatic progress. OpenAI's ChatGPT, released in 2022, demonstrates an ability to engage in human-like conversation, write essays, and even generate computer code. Such large language models, containing hundreds of billions of parameters and trained on vast amounts of text data, can understand context and generate creative content in ways that sometimes appear indistinguishable from human output. Computer vision has made equally impressive strides. Systems can now recognize objects, identify faces, and generate realistic images from text descriptions. OpenAI's DALL-E, released in 2021, showcases the ability to create photorealistic images and artwork from textual prompts, combining concepts in ways that challenge human imagination. The impact of AI extends far beyond impressive demonstrations. In healthcare, AI assists with disease diagnosis, predicts patient outcomes, and accelerates drug development. Financial institutions use it for fraud detection, investment decisions, and customer service. Autonomous vehicles, developed by companies like Tesla, Waymo, and Cruise, promise to revolutionize transportation through their ability to navigate complex environments and make split-second decisions. Manufacturing facilities employ AI for process optimization, equipment failure prediction, and quality control. In agriculture, AI monitors crops, predicts yields, and optimizes irrigation systems. These practical applications demonstrate AI's potential to address fundamental human challenges, from climate change to disease to poverty. However, this technological revolution brings significant challenges. The potential for job displacement raises economic concerns, though some experts argue AI will create more opportunities than it eliminates, as previous technological revolutions have done. Issues of bias in AI systems, trained on potentially prejudiced data, pose serious ethical questions about fairness in hiring, lending, and criminal justice decisions. Privacy concerns arise from AI's ability to process and analyze massive amounts of personal information, potentially enabling unprecedented levels of surveillance and control. The same technology that helps diagnose diseases could be used to track movements and predict behavior, raising questions about individual freedom and social control. Perhaps most profound are questions about artificial general intelligence, AGI, systems that could match or exceed human intelligence across all domains. This possibility, often called the singularity, raises complex philosophical and practical questions about consciousness, rights, and control. If machines can think, feel, and create, should they be granted personhood rights? These questions may require answers sooner than expected. The development of AI continues at an accelerating pace, with nations and corporations investing billions in research and development. The competition for AI leadership is intense, particularly between the United States, China, and Europe. This race makes it crucial to ensure AI development serves humanity's best interests rather than narrow commercial or political goals. The future likely lies in human-AI collaboration rather than replacement. In fields like medicine, law, and education, AI augments human capabilities instead of supplanting them. Doctors use AI for diagnosis support, lawyers for document analysis, and teachers for personalized instruction. This partnership model leverages the strengths of both human and artificial intelligence. Preparing for an AI-driven future requires rethinking education, training, and social safety nets to help people adapt to automated workplaces. It demands careful consideration of access, control, and governance to ensure AI benefits all of humanity, not just privileged groups. The development of AI must be guided by human values, wisdom, and a deep understanding of its implications. As we navigate this technological revolution, we must approach AI development with both optimism and caution. The potential benefits are enormous, from solving climate change to curing diseases, but so are the risks. Success requires developing AI systems that are safe, beneficial, and aligned with human values while maintaining transparency and accountability. The decisions we make today about AI research, regulation, and ethics will shape the future of human civilization. This responsibility demands wisdom, humility, and a deep appreciation for both the power and limitations of artificial intelligence. The story of AI is not just about creating thinking machines, it's about understanding intelligence itself and what it means to be human in an age when we can create new forms of intelligence. The AI revolution represents a pivotal moment in human history, testing our ability to use unprecedented power responsibly. As we continue this journey, we must ensure that AI development serves the best interests of all humanity, not just select groups. The future of AI lies in our hands, and the choices we make today will echo through generations to come.